Star is Born by David Stott. What's in your picture, Sam?
A process of a star creation.
Right, so it's a process of the creation of a star. So number one, it's an interstellar dust cloud, right? And that's the start of, that's what a star starts at. Number two is when it starts to collapse, okay? So this takes thousands of years, the collapsing process does. Number three is at the end of that process, the end of the collapsing, and the start of a protostar. Number four is when the new star is born, a new baby star. And number five is a solar system, so like where we are at right now, and that's hundreds of millions of years into the process. What's in your picture, Poe?
Interstellar dust cloud.
That's right, it's an interstellar dust cloud. So the interstellar dust cloud is tens of thousands of parsecs huge, okay? So a parsec is 3.26 light years. 1 light year is how far light can travel in space in 1 year. Okay, so 3 of those times that by tens of thousands, that's how big this is right here, okay? So it contains a lot of atomic and molecular gases with some interstellar dust, right? And it's so much, it's tens of thousands more than what's in our sun. The mass of that is that big, okay? And the temperature is about 10 Kelvin, which is negative 400 degrees Fahrenheit, so very, very cold. What's in your picture, Johnny?
I think of an interstellar cloud.
Right, so it's a collapsing of an interstellar cloud, so that's like the result of the gravity that kind of pulls everything in, and it concentrates in the center, and it begins to heat up and react with each other, right? And it lasts thousands of years. This is that process that I talked about with Sam. So let me kind of show you what happens with this. So this is just like a bowl, and this represents space, right? And these are the different gases that kind of come in, right? And they begin to form at the center, right? And the different gases and dust, they start to react with each other, and it heats up, and it forms what's in Porter's picture. What's in your picture, Paul?
A protostar.
Right, so that's a protostar. So the dust shrinks into the middle like that because of the gravity into a little pocket in space, and it heats up to about 10,000 Kelvin, which is 17,000 degrees Fahrenheit. Very hot, right? And then the heat and the gravity and the reactions that happen start to form the protostar, which is what's in Porter's picture. What's in your picture, Sam?
A newborn star.
Right, so that's a newborn star. So that's when heat continues to rise with all those reactions and all the gravity and all the pressure, and it heats up to about 10 million Kelvin, which is 17 million degrees Fahrenheit. Very hot. Not as hot as our sun yet. It's bigger than our sun, but not as hot. And then thermonuclear fission begins, and it starts to form a new star, right? And that's how a star is formed. Special thanks to